Hello Precalc students. This is a little bit crazy. I'm pretty new at this, so hopefully have patience with my video skills here. Hopefully everything works out. Hope you guys are all doing well. I'm trying to imagine you all sitting out there and talking to you. Yeah, pretty crazy. Alright, well, I'm going to go over chapter 9. So chapter 9, as hopefully you read, is on inverse functions. And the whole idea of inverse functions is inverse functions get rid of the regular function to just get x back. Typically they call the inverse function, like if the regular function of course is f of x, they call the inverse function f to the negative 1 of x. And the idea is that if you have a function and you want to get rid of it, you take the inverse function of it and you just get x back. So the inverse function cancels out the function and you get x back. So for example, the classic one is like if, let's say, you know that the sine, and I know we haven't done trigonometry yet, but you've seen it before, the sine of x is equal to, let's say, 0.8, and okay, we want to know what x is. So what's x? To get rid of sine, we take the inverse sine of both sides. So we take the inverse sine of both sides. Inverse sine cancels out sine, and we just have x over here, and on the other side we have the inverse sine of 0.8. And so then we know that x is the inverse sine of 0.8, which we can plug into our calculator and get an answer. So that's the whole point. Inverse functions cancel out the regular function to get x back. So you can just get x back out of it. Yep, okay, so let's do an example. So let's do example 9.2b, which they say h of x, which we'll just call it y, because it's easier to do math with y instead of writing h of x all the time. Y is equal to 5 over x plus 3. And I'm doing 9.2b because if you can do b, you should be able to do at least number 1 and a also. Okay, so we want to find the inverse function of this. And when it's an algebraic expression like this, it's not like there's a thing like inverse sine. All you do is you solve for x as a function of y, and that's the inverse function. So really this is just an algebra problem where we have to solve for x. So let's see, we have this equation here, y is 5 over x plus 3. If we switch the y and the x plus 3, we have x plus 3 equals 5 over y. Or then, take away 3 from both sides, x is equal to 5 over y minus 3, and that is our inverse function. So we could say that h negative 1 of x is equal to that. So that would be our inverse function. And if we plugged 5 over x plus 3 back in, we would just get x back. So let's try that. You don't have to do this, but let's try that because it's fun. So plug in y equals 5 over x plus 3 there. So right now we have x is equal to 5 over, and then y, we're going to plug in the original thing, which is 5 over x plus 3. Sorry, now you can see it. Okay, I'm still working at this. Okay, so plug in y is 5 over x plus 3, so 5 over x plus 3. And then minus 3. And let's see, 5 over 5 cancels, x plus 3 in the bottom of the bottom is like x plus 3 in the top. So that's equal to x plus 3 minus 3. And sure enough, we just get x back. So the inverse function of the function gets x back. Okay, that's the idea. Now the other thing they want you to do is the whole domain of inverse functions. And the cool thing is the range, the domain of the function is the range of the inverse function, and the opposite is true too. The range of the function of the regular function is the domain of the other function. So here the domain is we can't have x equals negative 3. Okay, so the domain for this thing is that x cannot be negative 3, but it can be everything else. And often that's written that something like x, but x is not equal to negative 3. Or you could go, well, yeah, if it's just one value, it's not worth the trouble doing all the greater than or equals or anything. You just say it can be anything you want except x can't be negative 3. That's the domain. And what about the range? When x is -3, that gets to infinity, but we can make this pretty much anything we want, right? If we made x negative, we could divide by a small negative number to make it really big. So really, the range for this thing, the range is pretty much x can be anything, and so we can say x is greater than or equal to -infinity, less than or equal to infinity, or you could just say -infinity to infinity. Yeah, so the range can be anything. So of our inverse function here, except, okay, here's the deal. Sorry, that was wrong. We cannot make this 0, because the only way to make this 0 is for x to be infinity. Infinities aren't allowed. So really, what I just said, okay, oops, sorry, this is kind of wrong. The range can be anything, except we really can't make it 0, because to make it 0, we have to divide by infinity, because 5 or anything over infinity is 0. So 0 is not allowed. So actually, let's cross that out. Our range is x can be anything except x cannot be 0, because infinities are not allowed. And again, to make this 0, we have to have an infinitely big number in the bottom, because then it's a tiny, tiny fraction, which is 0. So x can't be 0. So the range of the function is the domain of the inverse function. And remember, this is our inverse function here. And notice that the domain is y can't be 0, because then we're dividing by 0, but y can be anything else. So the range of our function is the domain of the inverse function. So this would be the domain. So the domain of our inverse function is this. That's the domain, because it's the range of the function. You got to be careful of that one. I'll say I wasn't. That we cannot make this 0 except x has to be infinitely big. We can make it anything else, which is what I was showing here with the -infinity, but we can't make it 0. I guess really I should have said y here. It gets really confusing between the x and the y's. Y, the range, can be anything except the function can't be 0. Alright, well, hopefully I didn't confuse you too bad. But that's the way you do these. To find the inverse function, you write it, the function as y, and then you solve for x. You figure out the domain of the function, that's the range of the inverse. Figure out the range of the function, that's the domain of the inverse. Or you could just look at the inverse and figure it out, and it should go backwards. So, alright, thanks for listening. Hope this is working for you. I'm new to this, so and I'll make another one with 9.2D next, because that's a pretty tricky one, but the other ones you should be able to figure out. And then I'll probably do another one later on with one of the later problems. So this should get you started. So, okay, thanks for listening. Bye.